Okay, so I'm excited to introduce Bill. Bill Peachy has been a student of the natural world his whole life. His interests have ranged from entomology to geology to botany to the study of bats. And he has also spent considerable time crawling around in caves. He was instrumental in the design of the cave installation at the Arizona Sonora Desert Museum exhibit. And in fact, he advocated strongly for the wonderful holes in it, which we have always called wormholes, where children can disappear into the cave, much to their delight and much to the consternation of their parents. His in-depth studies of saguaros over many years have resulted in many new insights and discoveries. And I think he could claim the title of Saguaro Man, and I don't think anyone would dispute that. So please join me in welcoming Bill Peachy as he takes us on a journey of our Sonoran Desert with his presentation, Saguaros in the Future Tense. And even though he can't hear us, he will know that we are all applauding.
So Bill, now you start talking and your picture will fill everyone's screen.
All right. So tonight, I'm going to be your pilot on a journey from the present into my scenario of a future for saguaros in part of this area. We started working out in Rincon Valley in 1997. So this coming year will be a 25th year working on these saguaro projects. Started off innocently and fell into the black hole of many, many different subjects. But tonight, we want to find out what's in the future for saguaros in this area. So we're going to be flying right into the face of bad weather. We are going to face extreme weather events. So if you want to take an antidepressant before this talk, please do. But then if you have any loose objects, put them in the bin above your heads. Make sure your seatbelt is latched and your tray is locked in its upright position.
So share your screen, Bill.
Okay. So it is October 8th. There are two ongoing events I noticed today, one tonight, kind of oriented towards climate change, some of our activities. There are two new fires down by Nogales tonight. I don't know if you saw the smoke over the valley as you came into the valley. Also on national news, they were talking about politics in Phoenix, and behind them were saguaros, one of which was heavily damaged by the heat event of 2017, I noticed. So there are ongoing things on this earth, and this earth is not a quiet place. It's trying to keep a balance that it will never make. The differences in the textures and energy absorption of the ocean, the albedo of the ice at the poles, the clearness of the sky for water to penetrate the earth, they all load the earth unevenly with heat energy. And we're facing an increase in that because of gases. And we have this thing called climate change. We're looking at things that have never happened before. We're looking at phenomena that aren't so great. Some are, something interesting. This first slide is the NOAA projection of rainfall on North America, on the US. And you can see since from about the 1960s, an increase. Well, why is that? It's because as you're boiling water, if you increase the heat, you increase the rate of boiling and you put more moisture into the air. So as our atmosphere heats, it's able to pick up more moisture and often it dumps it over land. That's an overall climate change in aggregate. Here, we're not so good. We're not having fun because we're in a drought area and it's going to stay a drought area for we don't know how long. So some areas get water, some areas don't. We're unfortunate, but we're in this drought area and it's going to stay that way for a long time. So our saguaros are here. They've been here for a long time themselves, and you can find them up to about 5,000 feet higher on south slopes, lower on north slopes, up into oak grasslands. And people would like to know where they're going to be in the future. People are already asking, are they moving yet? Are they moving north latitudinally? Are they moving up the slope? No, absolutely not. And we're going to discover why in a little bit. My main area of interest for data has been the Tucson Valley subregion of southeastern Arizona. This area between the Tucson Mountains, the Catalinas, and the Rincons, down towards the Empires, up towards the Tortolitas. It's a higher area at its base than, say, Phoenix, which is about 1,100 feet. My saguaro phenology plot is down here by Colossal Cave, northeast of Vail. Here's the plot, and my friend Tom Bethard is here with me tonight, and his wife in the past, and other people, the Smith family, have been working with me on this plot ever since 1997. The city of Tucson is off to your right, below the mountains. That's 27 miles. The plot's at 3,500 feet, and it averages about 135 reproducing saguaros per year. The major effort in saguaro research was bolstered in the late 1970s into the early 80s by the National Park Service. Unfortunately, a bacteria seemed to be attacking the saguaros, and they did a lot of research to find out how to get rid of it, what to do, and what was going on with saguaros. It was focused on a mortality perspective. And so they looked at other things in that way. They looked at lightning, they looked at pests, they looked at wind and fire, and they eventually settled on the idea that it was not the bacteria that was killing the saguaros. It had actually been a freeze in 1937, and 30 years later, saguaro mortality had increased and the bacteria were the last stage. So they quit attacking the bacteria, and it kind of became intellectual inertia because all anybody talks about is cold limiting the saguaro. That's what limits the saguaro. I decided to take a different perspective to look at these other items and this major element, cold. And that's what we're going to do tonight. We're going to look at cold, another major element, and some of these peripheral things. But we are going to look from the perspective of reproduction. Mortality is kind of a binary thing. It's on or off, the plant's alive or it's dead. There's so much that can happen between its reproductive activities start and its death. And people weren't looking in that perspective. Park Service came up with this statement through their two researchers, Steenberg and Lowe, and you cannot find a more incorrect statement. I just cannot believe two ecologists came up with this. Everybody should read this. All right, you speed readers. Got it? All right, moving ahead. So a few years after I got started in 1997, I hit a heat event. I later found out that it was coupled with low winter precipitation, and that was affecting reproduction too, as well as cold. So we'll cover that later. But I want to cover one of those also ran things because it's big in people's mind. I just mentioned two more fires. In the last 2 years, we've had 3 major fires. 2 up in the Phoenix area, northeast of Phoenix, towards the Four Peaks area. And of course, our Bighorn fire this summer. The Woodbury fire was in 2019, and it burned the mountains to the south of the Salt River, east of Mesa, the Superstitions, clear to Roosevelt Lake. Okay. Bighorn fire we know about roughly here. The Bush fire, which started after the Bighorn fire and is a much bigger fire when it ended up, was north of the Salt River and west of Four Peaks, but it burned clear around into the Tonto Basin at Mount Ord. If you know that road, the Beeline Highway, you go up through Sunflower and you go through the canyons and you go around the north end of Mount Ord. These all burned in the Saguaro zone. They all burned so fast, the firefighters couldn't get lines around them. And I just made a crude estimate of the total square miles in Saguaro, but actually it was much more than that. Here's the Bighorn fire, almost at the end. It actually ended up being 121,000 acres. Started over here in Push Ridge and ended up down into the San Pedro Valley. Well, a lot of this area is saguaro turf, maybe as much as 60%. It was not man-caused, it was lightning caused in one evening. I don't know who took this picture, but it's an incredible picture. That's Push Ridge and the lightning behind it. Tucson is on the other side of that ridge. And we all saw dramatic pictures like this. This is actually what I call an optical delusion, because it's not dumping fire retardant on the slope that you see with all the saguaros. That's foreshortening from a telephoto lens. It's dumping in a canyon on the other side. But you get the idea. We're not used to fires down at low elevations. Here's a late stage picture. There's one stringer of smoke here, and then more over in the San Pedro Valley. You can see it pushing up the troposphere here and down low everywhere. We all got sick of it. And then the aftermath, Catalina Mountains, Bighorn fire, drainage. This is part of Canada del Oro, a charcoal slurry, a nasty thing in its own right ecologically. But there were other fires. The Tortolitas had this little dove fire, and it just went along minding its own business. You can see plenty of grasses down here. You can certainly see some saguaros. I'm sure that succulents were taken out by this fire. No flame tongues, no flame-driven fire front winds that the fire's making itself. It's just going along, creeping. Well, that's quite a difference from what we saw in the Catalinas. There's the Catalina on Push Ridge, and you can see a fire tongue going clear up this steep slope. Wouldn't have done it except for invasive grasses. And that's the key to some of these fires, invasive grasses. So what's happening is you're getting a death of a lot of succulents. If they're not dead now, they will be in a short period of time. You're getting complete disturbance of the substrates because these fires burn so hot that they actually can spall the rock, the bedrock. And they're destroying the seed banks. They're destroying the biota in the soil, structure of the soil to promote erosion, which is going to promote pollution. And who knows what the fire retardant is going to do on succulents or the desert vegetation. I don't think there's any data on that. Somebody maybe can help me out with that one. So here's an event. And here's a result of the bush fire, not brush. I noticed that today. Miles and miles along the Behind Highway of dead saguaros. These are the big maximum producing saguaros, multi-armed. You can imagine the bird communities, the bats, everything else using these. But look at the soil, look at the open areas. You see ash down there, and that's probably from the grasses. So the flame tongues run really fast in these fires. They burn really hot and they're gone. The firefighters can't keep up with them. They've just been letting them burn. So how long has this been going on? I don't know, but there are lots of little tiny fires that the Forest Service has record of. They're only 2,000 acres, only 8,000 acres that are in saguaro land. So this may become a major ecological problem in the future. I cannot imagine saguaros reestablishing here anytime soon. They have no nurse plants. Who knows what's happened to the soil? They're obviously this year not getting any rain there. And so once you have extensive areas where the saguaros are blown out, why will the pollinators even go there? Why will the seed dispersers even go there? So these areas will have to be colonized from the edge where it's undisturbed and where a new plant can be in sight of another saguaro so that it can be pollinated, because the pollinators aren't going to go out into these vast expanses. They're going to know there's nothing out there for them. And it could be a long time before saguaros establish in a situation like this. So back to the cold. Cold is the major one. It's in the history books. We know from Forest Service work, from National Park Service work, that if you have a bad cold event, a freeze that attacks the growth point, the central mother zone at the top of each stem, each meristem, it can retard bloom production for several years afterwards. That's in the books. So that was the starting point, and I decided to define the elements to show the progression and see what was happening on my plot. So the first thing I want to talk about there is the spines. Everybody knows big spines on saguaros, whatnot, but they don't know, a lot of people don't know, that if you get above about 10 feet on a stem, it's a different spine. It's translucent, flexible, sometimes curving, not a big hefty spine. These spines do not protect the plant from weather. They're not dispersing sunlight in an effective way. They're not insulating against cold. It's easy to see, however, though, if they're growing, because they're nice and golden, you can see them glowing. But more important for this discussion, the spine areas are the start of cold damage in every saguaro. This is where cold damage starts because the spines are dead and they conduct heat away from the plant. And so the cold damage starts with what I call marooning, right around the spine area, grows to connect the pleat crest, and then proceeds down into the troughs. Here's a sonita. It's also the same effect on an organ pipe. You can see this is the stem tip, and it's starting down here around these, and it's more intense where it's more exposed up here. Marooning can be recovered from. This is just like a maple leaf. It's showing a red pigment because of the lack of chlorophyll. Oftentimes the chlorophyll will come back, but oftentimes this will stay marooned until another event takes place. So marooning is not so bad, but it's the first visible sign of freeze damage. Here's the one everybody was concerned about years ago, thinking that it might be caused by air pollution. This is epidermal browning. You can see the progression of the browning here. It's covered the pleat crests, and it's starting to work its way down into the troughs. So that's the progression of events at that scale. Over time, the browning starts at the bottom of the plant and goes up. And the reason for that is cacti have an epidermis that's unusual in the plant world. It doesn't die at the end of the season. The epidermis on a cactus is meant to last the life of the plant. But as we all know, life ain't perfect. So successive cold events increase the amount of browning until that surface becomes non-functional. It may bark over, or it may turn all brown. So the oldest part is attacked first, and successive freezes will run the browning up, and sometimes it'll even get up onto the arms. But you can see this stem here is green, still green. Here's what's happening. The epidermis is so tough that it can freeze underneath it and leave no sign on the surface. This tissue is dead or dying, non-functional, yet it's green on the surface. That's one of the reasons why you don't pick up the rot in cactus. It's rotting on the inside, and you can't see it till it finally breaks out an old lesion or finally busts out through the green. So you can have successive freeze damage working its way in unseen on the surface. Here's the ultimate, 2011. The crests of these pleats were killed. So these spine areoles, which are the growth points for buds, flowers, and fruit, and maybe a new arm, they're out of the picture forever. It's killed this tissue. And then skipped a year, and it froze in 2013. Here's the damage from the other side I just showed you, brown and then green. So there's damage probably underneath this green going quite a ways. Without cutting in there, you can't tell. So this is from one event. I was told by the owner, this cactus was in perfect shape until 2011. And here you can see the sign of 2 freeze events on it now. So it's cutting back on its photosynthesis, cutting back on its ability to reproduce, because these spine areoles are no longer functional. The other thing is, and this is a spectacular example because it has no freeze damage, 2 cactus side by side, probably 2 feet apart, different response to the same events. So the thermal mass of this is probably bigger and big enough that it retarded the damage. You can see a little bit of a neck there. But on this one, you can see a sausage link for 2011 and another link for 2013. The residents watched this and kept record of it. It's in the Catalina foothills. So in a sense, bigger is better as far as a saguaro goes, but it's not absolute proof because these bad events stack upon one another. Here's the result on my saguaro plot of good old 8007. Not in good shape. It had freeze scarring here, but its overall green is about the same as this healthy single-stemmed one to the left. But it froze in 2011. This is 2010. DRT is the military term, dead right there. But look at the babies. If you could get close, you would see no marooning, no cold damage. They'd never been frozen before. They're still resistive. If they are having damage, you can't see it. But they're doing fine. They're probably twice this height now. So here's one that's had successive damage. It's been weakened. You can see it's not in good shape. The stems are getting pointy instead of big and round. It's not producing many flowers. And so the cold comes along and wipes it out. And everybody knows about these. This is a good sign of cold damage. The fallen arms. This only happens from freezing. The connection with the main stem is almost all wood. There's just a centimeter or so of material there, and it freezes underneath the epidermis, turns to slush, and the skin rotates over the wood and drops the stem down. These never recover. They will start growing up. Eventually, they'll be so long and heavy, they'll break off. So that's one freeze damage stage that everybody knows about. The big freeze was in 2011, 20-some degrees off the norm for January. Nasty, nasty event. Temperatures down to 7 degrees. And people forget about this. Maintained speeds of the wind were between 20 and 30 miles an hour. It created minus 20 degrees in the foothills and minus 30 in the chaparral zone above. Why do I say that? Because we're talking about the characteristics of climate change. The main one is more bad weather events. And some of them will be more intense. Well, this was an intense one because for the first time ever, oranging. You ever seen a saguaro like that? This is flash killing of the chlorophyll. These plants are dead. Here's a color bar you can compare with. This happened all over this area. Here's one at Dove Mountain 7 months later. Actually, some of the stem tips were still green, but this plant's just shriveling and dying. So that's a characteristic of the global warming damage. So the second big thing that we discovered was heat damage. And we thought it was just heat at first, but we've come to find out it's prefaced by a lack of winter precipitation. And the damage does not show up until after the bloom is over. Here's the very first record of it. Good old 2101 and 3001. Their central stems leaned over. You can't really see it in this picture, and they yellowed. It was not sun bleaching. They're yellow all the way around. Here's one you can see the yellowing on a little better. Really unusual. We started tracking it. Here's 5 years later, same cacti. When the central stems bend over like this, they never recover. Later, if it bends at a boot, it may break off due to cold because the xylem and phloem have been pinched off and it's not exchanging warm water to keep itself from freezing. And so people attribute the central stem falling over or the top of it breaking off from cold. It actually started bending from a heat event. The tops only bend from a heat event. The arms usually are not affected in drooping. They may turn yellow if it's a severe case. So here's the winter moisture recorded from calipers diameters on Tumamoc Hill by Owen Davis. And we've got 2 years here, and you can see the summer slimness of the cactus is at its worst right when they bloom. Then they get summer moisture, it drops off, and they get winter moisture again. And the winter moisture is thought now to supply the blooming. There's people working on oxygen isotopes in the saguaros to prove that. So all of a sudden, the yellowing came back in 2017, and that's the yellowing you're seeing around town. You really have to know the saguaros over years to parse out how the stacking of this damage is occurring, because cold events will stack on these heat events and vice versa. So you need to know the earliest event that it affected it, and then you'll see this bending or other types of bending. Figuring out the leaning and bending is very difficult because you have to throw in wind. Wind will often whip the plant back and forth and break roots that'll cause leaning. So that's pretty complicated. But I think everybody can see this saguaro is yellower than its mates on this hill. And it has this funny bend from losing turgor. This was all over. Here's out on my plot, surrounded by healthy saguaros, not affected. This huge, the bigger one, plumper one, had severe heat damage. Pima Canyon, same thing. Cabeza Prieta, same thing. So this is a regional effect. So here are 4 or 5, 6 cacti that exhibit what's going on. This is epidermal browning. I don't know if you can see that it has the brown shade. This is obviously the one that's heat and water loss damaged. Whoops. Let's see here. We got to go back. Go back here for a second. Yep. There we go. And here are 4 in the middle that are going along just fine. If you notice, there's not a lot of cold damage on these, and these aren't heat and sun damaged. So there's a little scenario of the whole process there. So we get into other weather things, and rainfall is a big one. Sometimes we do get rain. Years of rain on a 20-year moving average, and it shows a decline of about 4 inches or so over a 20-year period. But it's not enough detail. So what my friend Tom did was graphed it 3-dimensionally. Here's the water year, and here are the years down here. Winter is in the foreground, and then you see the Alps of the summer rain. Each color is 1/10 of an inch of rainfall. This represents a decline of the winter precipitation by 0.8 of an inch over a 20-year period. With the last 3 years added on, it's to a full inch of loss of winter rain. And remember, I'm talking about winter rain being crucial for the summer bloom. So the overall conditions are declining for saguaros as far as precipitation goes. And there are other things I can't show, we don't have time. But Park Service came up with this. This is incredible. Yes, this is a lot of fudge in the kitchen of estimation until the 1940s when they actually started really being careful measuring. But these are the established saguaros on a yearly basis for the study section 17. It's in the northwest corner of Saguaro East. 87, a peak over 400 per year at that rate. It drops down. 90, 91, it plummets to the cellar. The initiation of the drought hit. Remember that? Trees were dying at the head of the Santa Cruz River because the base water table level was dropping below their roots. That's when that all started. We're still in it. And this is the coup de grace. This is 18 years of blooming production on the research plot 11 of 18 years are in the green. They're normal. There's nothing recorded that significantly dropped the production. If you average those 11 years, you come out with 9,000 blooms a year. But we have these other years in. This red one was heat and water loss, no winter vegetation, only 100 blooms, no fruit. Remember that statement I had you read? That saguaros are independent of moisture and weather, regardless. They're guaranteed to produce. Not even close. 5 years of freeze damage. Here's 2011, 12, and 13. Mark Dimmitt noticed this. After a bad year, you'll often have a great big huge year. And there's some big ones following these bad years. This one, the juicy berry one, that's a combination. And this is one of these factors like fires coming in. This is from heat, water loss, and bugs. There's a true bug that attacks the reproductive structure of the saguaro. It's the principal herbivore of the saguaro reproductive system. And this year is the only year that it significantly attacked the first couple cohorts of buds and dropped it down into the category of being below average. So here's the running average of the plot. And these guys cause about a 2,500 bloom drop. So the saguaros on this plot are suffering from heat. They're suffering from cold. They're suffering from bugs in significant ways that are dropping the production by about 27%, about a third. And that's not good for the future. So, getting to the end here, hold on. What about our future? My prediction is that at least in the area where my plot is, and a good chance the eastern part of Pima County, the rest of the world I can't tell you about because there's no data. But instead of moving north, until the weather settles out and decides what the climate is going to be in the future, the saguaros in the area I'm interested in are going to look like they're going extinct because they're not establishing. They're not producing enough seed to equal their numbers. The weather conditions are beating them down. The bad events are happening. There are 7 bad events there. That's 39% of the years. That's almost 4/10 of the years are bad years. The bad years are happening so fast, the saguaros can't recover. And like I say, I think they're going to start declining in patches, maybe not areas, maybe not all areas will have this problem, but at least the head of Rincon Valley, and I'd be willing to guess the east side of the Catalinas too, and Saguaro National Park East, they're not establishing, they're not going to establish. The bad events are killing the big saguaros that produce a lot of flowers. And the next cohort that comes up is going to be assailed by these bad events. So you're talking 175 years from now, and then you're going to hit the gap of non-establishment, and who knows how long that's going to last. So I think they are going to decline.